There we go. Good afternoon, everybody. How are we doing? Thank you for joining us here. Today, we're going to take a look at electrical power monitoring with HOBO data loggers. My name is Scott Ellis, and I'm a product marketing manager here at Onset. Before I turn the presentation over to Matt Panadosi of the Catalyst Group, I'd like to give you a brief introduction. Just a quick overview on who Onset is. For those of you who may not know who we are, we're the worldwide leader in data loggers. We were founded in 1991. We've sold, 1981. We've sold over 2 million data loggers, and we're located in Bourne, Massachusetts on Cape Cod. We do all of our manufacturing and developing here, and we have roughly about 120 employees with a worldwide dealer network. Just a couple details about the webinar. We're going to run about 50 minutes here and then open this up to questions for about 10 minutes or so. So if you do have any questions as this is going along, please type them into the questions screen, and we'll address these the best we can at the end. We are recording the webinar today, so you will receive a follow-up email with a link to the recording. And at the end, actually, make sure you do fill out the webinar evaluation. We like to try to improve these the best we can, so your feedback is critical. All right, so we'd like to welcome Matt Panadosi. He's an associate engineer and a master electrician for the Catalyst Group. He has 12 years of experience in the electrical field and 5 years in energy efficiency. He's installed thousands upon thousands of data loggers in residential lighting to industrial power, and leads the field measurement team and oversees safety operations at Cadmus. So we will get this over to Matt.
All right, thank you, Scott. So today we're going to talk about power metering. We're going to talk about the HOBO data loggers that we'll use today. We'll go over some important electrical safety considerations. We'll talk about who should be doing this work and things you need to know. And then we'll get right into energized power metering and then tie it all together with the logger installations. So some of the equipment that we're going to be discussing today is the Onset U12.
Hang on. You want to put that on?
Excuse me. Okay, so some of the equipment we'll be discussing today is the Onset U12 with a CTV, the U30 with a Wattnode, and finally the UX120 data logger with the E50B2 power meter. So, important electrical safety considerations. Today's presentation will provide an overview of installing power metering equipment in electrical panels. This presentation will not qualify you to perform such installations. It is critical that only qualified persons with the appropriate knowledge and safety training install these devices. Failure to do so will result in major injury, loss of life, and/or property damage. We recommend only licensed electricians for this type of work. A few safety statistics before we get too far. On average, about 30,000 electrical contact injuries occur annually in the United States. Electrocutions account for about 10% of construction-related deaths. 50% of these occurred on less than 600 volts, and it's the fourth leading cause of industrial death. Only 7.5 watts at 120 volts is more than enough to kill you. A few other notes. Copper expands by 67,000 times its solid volume during an event if something shorts out. Sound can exceed 160 decibels, rupturing the eardrum. Shrapnel leaves arc blast at an area at speeds exceeding 700 miles an hour, fast enough to completely penetrate the body. Pressure wave can damage lungs, brain, and central nervous system. So when you're installing electrical equipment, it's important to follow the 2012 edition of NFPA 70E. And basically what it says for electrical systems operating at 240 volts and above, it tells you to basically follow hazard risk category 2, wearing rubber insulated gloves and insulated hand tools. We'll show you what those tables are. So hazard risk category 2, you want to make sure there's arc-rated long sleeve shirt, arc-rated pants, arc-rated coverall, arc-rated suit, arc flash hood, and a jacket if you're working outside. Flame-resistant protective equipment, you'd need a hard hat, safety glasses or goggles, hearing protection, leather gloves, and leather work shoes. So we'll show you what each of those look like. So this is a typical face shield system. Note, in addition, you'll still need the safety glasses and hearing protection to be worn. Then you need a balaclava, and it has to have a minimum arc rating of 8 calories per square centimeter. And this is different from firefighter equipment. You then need an arc flash jacket, again, the same arc rating of 8 calories per square centimeter. And you can also wear a flame-resistant shirt having that same rating. You then need rubber insulating gloves for the voltage, and then leather protectors to protect from the heat and puncturing the gloves. Followed by flame-resistant pants and overpants. Again, different from firefighter equipment, and then leather work boots. Many facilities that you work in will require steel toe shoes. And now getting into safe work practices, this is an example of how you should suit up when you enter these panels. A few things we do at Cadmus: never wear synthetic clothing, including undergarments, never wear open-toed shoes, jewelry, or loose clothing, and always wear your safety glasses. Before we open an electrical enclosure, know how to shut it down in the event of an emergency. Always resist hurry-up pressure, take your time, and never try to attempt something you are not comfortable with. Use electrically insulated tools. De-energize the equipment before installing or removing data loggers. Obviously, that's whenever possible, because you would need equipment energized while taking voltage readings. Use a voltage tester to verify the presence of dangerous voltages, and remain in visual and audible contact with the workers performing the work. So it's always good to have at least teams of 2. And now we'll get into energized power metering. It is always best practice to identify and confirm the voltage prior to installation. This will help you determine the proper equipment you're going to install, and also help ensure that you're wearing the proper personal protective equipment. Start with a basic visual. Take a look at any labeling or color coding. On this panel here on the right, you can see that it's clearly labeled 480, 277 volts, and the color coding for that is brown, orange, yellow. So we know that we're going to be in the hazard risk category 2, so we'll need our full arc flash suit to open up that panel board. And some of the conventional color coding here in the U.S. For small commercial electrical panels, 120, 208 volts, typical to average plug load. You're going to have the black, red, blue on your phase colors, and a white neutral conductor. When you get into the higher voltages, such as commercial lighting or large pieces of commercial equipment, you could run into 277, 480 volts. And those are usually marked with brown, orange, and yellow phase colors and a gray neutral wire. This is not always 100% the case, but it's pretty conventional in the U.S. And here's a few examples. On the left-hand side, we see a 120, 208 volt electrical panel. And then on the right-hand side, we see color coding for a 277, 480 panel. So once we gain access, it's still important to confirm the voltage with a meter. Make sure that voltage meter is a double insulated and category 3 rating. So those $10 multimeters don't always work well in these situations. You want to make sure you have a heavy-duty meter that's rated for this voltage. Now we'll watch a short video on voltage testing. We'll now perform a voltage measurement on this energized panel board. We'll do so by wearing all of the necessary safety gear that we previously described. It's important that only qualified persons enter the panel board. Start with our safety glasses and hearing protection. And now our balaclava. And now I'll put on my 8-calorie arc flash jacket. And I'm wearing my 12-calorie arc flash pants. And I'll put my first layer of gloves on. These are to absorb the moisture. These are followed by my class 00 500 volt voltage insulators and my leather protectors. And I'm now ready to remove the cover of the energized panel board. We can see that the main conductors are black, red, and blue, so we know this panel is probably 208 volts. We'll confirm that with our voltage meter. We'll take our voltage readings with a Fluke T5 1000 meter. This is double insulated and good for up to 1000 volts. We'll set the meter to voltage, and we'll take multiple voltage measurements. We'll start with phase A to the neutral conductor. We should read approximately 120 volts. We'll then move on to phase B and phase C and get the same reading. We'll then check the voltage phase to phase, measure the voltage between phase A and phase B and phase C, and phase A and phase C. For this, we should read approximately 208 volts. Once we've confirmed our voltage, we can now install our data logging equipment in the panel. Okay, now we're getting into watt node placement. It's important that once we get into the panel and identify the voltage, we look at a safe location to place the watt node. We'll then do voltage lead placement. So take an idea at where you're going to tap the voltages. Again, in most cases, it's going to be 3-phase, so you're going to have a black, red, and blue voltage lead going to the watt node. Here's voltage leads on fuses inside a main switchboard or a motor control center. And here's voltage leads and CTs on a breaker. And here's a watt node and CTs in a 480 volt electrical panel. And then here's a complete installation in a smaller commercial electrical panel. We have our voltage leads at the top, followed by our CTs. Our watt node is located at the bottom, and the wire would run out of the panel to the data logger. So now we will look into single circuit amperage and how to log that. So for this installation, we're going to use a U12 with a CTVA. This method is best for to capture runtime. It could be used as a very rough estimate on energy consumption, but really we're just logging amps. So again, the best way would be runtime, and it's a nice compact installation. Typically the U12 will be outside of the enclosure, and the CTV will be mounted inside the enclosure on the circuit conductor. So we'll show a short video on how we install that. We'll now install a data logger on a single circuit to monitor the amperage. We'll do so by using an Onset HOBO U12 data logger and a CTVA, which is a split-core current transformer. This particular current transformer is not directional, so it doesn't matter which end the wire goes in. We'll be working with our demonstration panel board, which is de-energized, so we can focus on the meter installation. If this were an energized panel board, I'd be wearing all the necessary safety gear to work in it. Once we've identified the circuit to monitor, we'll install the CTV around the conductor and line up the conductor in the center of the CTV and clip it closed. And now we'll need to run the data cable on the outside of the enclosure. We'll do so running it through this fitting. That way it'll provide a safe method of exiting the enclosure. And we will now connect the data cable to our U12 data logger. And we'll mount the data logger with one of the many methods provided with the packaging, in this case a magnetic strip. And we are now ready to launch our data logger. Okay, and one other advantage of mounting the U12 to the outside of the electrical panel is you can do an interim site visit without the electrical safety gear and download the information off the data logger without opening up or accessing any of the energized conductors. So it's always a good idea to keep your logger outside of the panel whenever possible. We'll now look at logging single circuit power, and we'll do that with a Wattnode and a U30. This is a more complex than current metering, so we're looking at true power. Basically, the Wattnode is a kilowatt-hour transducer, and we can also derive kilowatts from that. For the example we're going to see in the video, we monitor a 50-amp three-phase circuit. The part numbers are a Wattnode TWNB-3D-240-P for pulse output. We use a voltage lead set provided from Onset Computer Corporation. That's the A-WNB lead set. I'll discuss that a little bit more in the video. Many options for CTs that plug into the Wattnode. If you go on Onset's website, you'll be able to choose the appropriate ones for the equipment you're metering. And then I'll show you how to tie that all together with a pulse input adapter, an S-UCC. And then we'll tie it right into a U30 data logger so then we can see our data online. So why don't we go ahead and watch the video on how to install a Wattnode on a single circuit. Single circuit using a Wattnode and a HOBO U30. Once again, we'll be doing this on our display panel board, which is de-energized, so we can focus on the equipment installation. If this was a live panel board, I'd be wearing the necessary safety gear. We'll start out by identifying a safe location for our Wattnode. For this installation, we'll use the bottom of this panel board right here. We'll locate our CTs on these conductors for this 50-amp circuit, and our voltage leads can either go up here or down here, or if available, they can go on these conductors. These panel boards are wired phase A, B, and C, left to right, and top to bottom. We'll start by wiring our CTs to the Wattnode. We'll use a split-core current transformer. Again, these are directional. I've also labeled the CTs black, red, and blue to represent the phase colors. These line up with the colors on the Wattnode as well as the colors in the electrical panel. We start out by wiring the black CT to the phase A terminal to the white and black terminals. We'll then wire the red CT to our phase B terminal. Once again, the white wire will go on the white terminal and black wire will go on the black terminal. And lastly, our phase C CT, the blue, will get wired to the phase C of the watt node. We're now ready to plug our voltage leads into the watt node. For this, we'll use the watt node lead set available from Onset. This particular lead set is double insulated and rated for 1,000 volts. Now that our watt node is pre-wired, it's ready to install. We'll place the watt node in the location where we've determined. We can now run the Onset pulse input adapter cable to our watt node. We'll do so using the listed fitting to bring our cable into the panel board. And we'll wire it directly to the watt node. This cable has a black and white conductor. The black will be connected to the common, and the white wire will be connected to P1. Normally we will not use P2 and P3. Now that everything is wired to the watt node, we can begin connecting our CTs to the phase conductors. We will start with the black phase A CT. This will go around the black conductor on our circuit. Once again, this particular CT is directional, so we want to make sure the arrow faces the source, or in this case, faces the center of the panel board. And this CT just clips shut to know we have a secure connection. We'll now move on to the red, phase B. Make sure the arrow faces the source, and this will go around the red conductor of our circuit. And lastly, our blue CT, phase C, will go around the blue conductor. And we'll want to tuck the CTs in deep enough to allow for the enclosure cover to be installed. We'll neaten our CT wires, and then we can move on to our voltage leads. We'll start with the green ground voltage lead. This can be connected to any part of the metal in the enclosure or one of the two ground bus bars in this panel. For this, we'll connect it up in this corner. We want to make sure it's nice and secure, and we'll run the cable safely along out of the way of the other cables. The next connection will be the white neutral voltage lead. In this particular panel, the neutral bus bar is on this side and this side, and for convenience we'll go right over here. Again, we'll make sure we have a good secure connection, and we'll neaten up our lead. Our next connection will be our phase conductors. These are the most dangerous connections we'll be making. For this, we'll connect our black phase A right over here. And once again, it's very important that the connection is solid and also not touching any other metal. We'll do the same with the red phase B conductor. We'll test our connection, make sure it's solid, and ensure that it's not touching any other phases. And finally, our blue phase C conductor will go to this bus bar right here, which is connected to phase C. Once we have our voltage leads in place, we can use a zip tie to organize them. And we'll tuck them out of the way of the enclosure cover. We'll want to see the indicator lights on the watt node once we repower the circuit. We can now plug in our Onset pulse input adapter cable to our HOBO U30 into any smart sensor port available. And now we're ready to launch our data logger. Okay. So basically for single circuit power, the watt node indicator lights will illuminate. They may begin flashing, and you want to observe the lights with the equipment running to ensure a proper connection. If all green lights are flashing, then you've done a good job and that's a proper installation. There are cases where red lights will flash or yellow lights, and refer to the watt node installation manual to help troubleshoot what those lights indicate. And one thing to emphasize is with the equipment not running, you might have slow green light flashing, slow yellow, slow red. That might be normal. So it's important, the only time to believe those lights is with the equipment running and with the watt node seeing a true load. Finally, we're going to discuss how to log whole panel power. So we'll do this, like I mentioned earlier, with an E50B2 power meter available from Onset and their new UX120 4-channel data logger. This is the most accurate monitoring method. This is good for multiple independent channels. Through this setup, we can do voltage, current, power, power factor, and energy all individually. This is a real nice setup for a permanent installation. So to do whole panel power, you must first determine the enclosure to monitor, identify external location for the equipment, and come up with an installation plan. For this type of installation, you're going to need to schedule an equipment shutdown and also follow the lockout-tagout procedures in NFPA 70E. We'll now watch a video on how to do this permanent installation. We'll now install a data logger to monitor the whole panel power. We'll do so by using an Onset E50B2 power meter and an Onset HOBO UX120. Since this will be a permanent installation, we want to make sure that we safely de-energize our panel board that we're working in. We follow the lockout-tagout process as described in NFPA 70E. For the E50B2, we'll install a standard 10-inch by 10-inch by 4-inch metal enclosure. We'll run a 1-inch conduit between the enclosure and the panel board for our 5 voltage leads and 6 CT conductors. For our UX120, we'll install a plastic enclosure with a plastic 3/4 inch conduit for our 6 communication conductors. For this installation, we'll use the Velcro mounting method in order to have ample space for our data connection. The E50B2 power meter will mount directly to the 39mm DIN rail. When we install the DIN rail, it's important that we leave enough room above and below for the wiring to the meter. To install the meter, we connect to the top half and then push down on the bottom half until we hear the click. Now that the E50B2 power meter is in place, we can remove the terminal covers and begin to wire it to the UX120. For this, we'll use the E50B2 lead set available from Onset. We'll run the black and white conductors up to the UX120. We'll start with channel 1 on the UX120. And we'll connect the channel 1 lead to the volt amp reactive hour terminal on the E50B2. We'll now connect our next conductor to channel 2 of the UX120 logger. This cable will connect to the watt-hour terminal on the E50B2. We will now connect our final lead to channel 3 of the UX120. And channel 3 will connect to the amp hour terminal of the E50B2. We can now organize our conductors with a cable tie. We can now install our 3 CTs on the main feed of our panel. Once again, these CTs are color-coded, black, red, and blue, with our 3 phase conductors. We'll start with the phase A CT on the phase A conductor. These CTs are directional, and it's important that the arrow faces the source, or in this case, faces up. And these CTs just clip closed. And we run our CT conductor back through the 1-inch conduit to our E50B2 meter to the phase A CT terminal. Because these CTs are directional, it's important that the white conductor connects to the positive terminal and the black conductor connects to the negative terminal. We'll now connect the red phase B CT to phase B of our panel. Once again, we make sure the arrow faces the source, and we clip the CT closed. We pull the CT conductor through the conduit and connect this to the phase B CT terminal on the E50B2. The black conductor connects to the negative terminal, and the white conductor connects to the positive terminal. Our final CT is the blue phase C CT. Once again, we line up the arrow with the source, connect the CT around the conductor, and clip it closed. We'll run our final CT conductor through the conduit to the phase C terminal of the E50B2. The black conductor once again will be connected to the negative terminal, and the white conductor will be connected to the positive terminal. Now that all of our CTs are installed, we can organize them with zip ties. Then we'll pull the excess wiring into the enclosure. And once again, we'll organize these conductors with a zip tie as well. We can now put our terminal covers back on the top terminals of our E50B2. We'll now install our voltage lead set on our power meter. We'll connect the phase conductors to the lower left-hand side, and we'll also connect conductors to the lower right-hand side to power the meter. We'll start with our green ground connection. This connects to the left-hand terminal of our control power block. Our next connection is our white neutral conductor. This will connect to the far right terminal of our voltage input terminal block. We will now connect our black phase A terminal conductor to the far left phase A terminal, as well as terminal number 1 in our control power terminal block. So we bring the black phase A conductor together with the terminal 1 conductor on the control power using a listed terminal. We'll now make the same connection for the red phase B conductor, connecting that to terminal 2 on the control power. And we bring the red phase B conductor together with terminal 2 on the control power using a listed terminal. We'll now install the blue phase C conductor to phase C on the voltage input terminal block. Now that all of our phase conductors are installed, we can install our terminal block covers. We're now ready to bring our conductors into the panel board. We will now connect the green ground wire to anywhere on the ground bus bar, which is right up here. We'll now connect our white neutral conductor to the neutral bus bar. And now we'll connect our 3 voltage leads to a circuit breaker. For the safest installation, it's recommended that we use a 15 amp circuit breaker and we connect it right into the bus bar. It's also important that the breaker phases line up with the panel. In this panel, we have phase A at the top of the breaker, followed by phase B and phase C. We'll connect the black conductor to phase A. The red conductor to phase B. And the blue conductor to phase C. Since this is a permanent installation, we can now organize our conductors. Once all the wiring is in place, we can double check everything and turn our panel board back on. Once this is done, we can turn on our new circuit breaker, and we should see a display on the E50B2. And now we're ready to launch our HOBO UX120. Okay, well, hopefully by this time you've seen all the videos, and in the meantime, we've gotten a lot of great questions, and in the next 15 minutes, I'm going to do my best to address them all, and we will be available to address even more questions after. And like Scott had mentioned earlier, this video will be posted online, and you'll be able to review it again. So the first question was in regards to personal protective equipment and where are good resources to buy such equipment. The quickest answer is Grainger. They might be on the pricey side, but they typically have things in stock. So if you go to Grainger.com, they have a whole section on safety and electrical protective equipment. There's also another great website that we deal with a lot, and that's frsafety.com. Slate Rock Safety, they specialize in safety gear, and they have pretty competitive pricing. So those are a couple of resources for you to get PPE. Another question was in regards to a qualified person. I know I use that term a lot, and what does that mean, licensed electrician and everything. And I took the term qualified person from the National Electrical Code. In the beginning of the code, there's a definitions section, and they actually define what a qualified person is. And I'll go ahead and open up the code book here. And basically, qualified person means one who has the skills and knowledge related to the construction and operation of the electrical equipment and installations, and has received safety training to recognize and avoid the hazards involved. So when we say qualified person, they have the knowledge and safety training, so they know what they're working in. We had another note regarding arc flash, and it looked like by default I was using hazard risk category 2. For your smaller commercial panel boards, typically this is good enough, but it's always important to have a arc flash analysis. And typically, if the panel board is done right, there'll be a sticker on that panel board, basically instructing the person working in it exactly how much safety gear they need, what level. What we showed today was just one of the smallest, lowest levels of safety gear. If you're getting into main panel boards for big buildings, then you're going to need to dress a little bit more like a spaceman, a lot heavier equipment, and you're just going to want to make sure you know that. And the facility electrician should be aware of that, and they should be able to guide you with the right equipment. No two panel boards are the same, so it'll be really important to know the safety hazards associated with the equipment that you're working in. We had another question regarding U12s and with the CTVA setup. In regards to, is it good to determine the proper amperage on the phase legs of a commercial HVAC system and the controls? The U12 with the CTVA, like I said, it's a great tool to record amps, but what it's doing, it's only taking a snapshot of the amperage. So depending on what type of data you're looking for, in some cases that will be totally fine. In other cases, it's not good enough. There's usually with HVAC equipment a power factor associated that the CTVA will not see. So if you try to use it to estimate energy or estimate power, that's not going to be your best tool. You're going to really want to use a Wattnode or an E50B2. But again, if you're just looking at amps, you can put one of those on each phase. There's multiple channel U12s that you could get. So you're able to, with a single U12 capture 3 different phases of current with a CTVA. So just pay attention to your logging interval and also the memory of the U12, and make sure that it's large enough to satisfy your project's duration. We had a lot of questions regarding CT direction, and this can be a real confusing topic and something that could throw anyone off. And my best recommendation for CT direction is check with the manufacturer's instructions. The CTs that we deal with and the ones that I'm familiar with from Onset, in I think all of the cases, the label or the arrow points toward the source. That's true for a lot of your MagnaLab CTs and your Blue Continental Control CTs that have the arrow, it faces the source. They did it completely opposite of some of our voltage meters and our fluke meters, AEMC, where the arrow actually points toward the flow of current, meaning points toward the load. So you're going to want to make sure that if it's you or your electrician, you're very aware of what that arrow means, because it doesn't necessarily mean point toward the source or point toward the load. And we had another question regarding, well, what if the CT doesn't have a direction on it? Can you assume that it's not directional? I would say maybe, but again, I'd really refer you back to the instructions of that CT because they'll specify. Like I had mentioned, the Onset CTV is not directional. It says it right in the manual, but other ones are directional. And there are even other cases where the direction, even though the CT is directional, depending on where you plug it in, some cases it might not matter. One example is the TRMS module from Onset. You can use a directional CT, and the direction actually does not matter. So check long story long, check the installation instructions, and that will guide you. If not, our friends here at Onset will be able to help you through the installation. And we had another great question on where to connect the phase, where to connect your voltage leads on the phases. We had a really ideal situation that I showed in the videos. There was open bus bar there. I don't always recommend connecting directly to the bus bar. That's the most dangerous area, but in some cases, again, if you're qualified to work in that panel and you know the hazards, you could connect there. But in reality, these panel boards, they're going to be packed with twice the amount of wires. The breakers are going to be full. What can you do? That's always the question. And really work with an electrician. They can make some space, free up some breakers, or I'm going to use the term double up wires under a breaker. That doesn't necessarily mean stick two wires in the same breaker. It means shut that breaker off, use a wire nut with your Wattnode voltage lead and the wire that's attached to that breaker, and bring a single wire into that breaker. So work closely with an electrician on that. They'll know how to tap the voltage safely. Another thing that ties right into that question is I talked about these voltage leads, 1,000 volt insulated. These are really nice voltage leads. Obviously, there's a pretty high price tag to those. I think they're maybe approximately $70. Are there any other options? Yes, absolutely. You can use standard electrical wire, type THHN, the rolls of it that I used in the final video there. You can get those at your local electric supply house or big box store. Those are totally fine. You want to make sure it's rated for, it has that 600 volt rated insulation, and those you would tie right to a circuit breaker or an open terminal, or if there's a relay with available terminals. Again, working with an electrician to make that determination. We always get the question, well, what size wire? I would check the Wattnode manual. I think anything 16, 14 gauge, right around that area is a great size to use, easy to work with, and again, make sure it has that 600 volt insulation. Don't use thermostat wire or telephone wire or anything like that. You're just, it could be very dangerous. So spend a few dollars, get the right rated wire and equipment. Okay, we discussed that. And one other question we got in was regarding my last video. What is the average installation time and material cost? Now, obviously, I did that video in maybe about 15 minutes or so. Does it really take 15 minutes? Absolutely not. There was a lot of prep work behind the scenes. So the quick answer is it's really going to depend on the panel in the building. There's so many variations out there. I would say on average, make sure you schedule an electrician for at bare minimum a half a day, but probably a good healthy day's worth of work. You know, typically this will be done on a Saturday or where you can safely de-energize it without interrupting normal business. There's a lot of figuring that has to go in. It's not one of those jobs where you can just show up with a pile of data loggers and equipment, going in blindly, connecting everything, and then walking away. It does take a lot of planning, consideration, and coordinating with the building staff. And I think that was the final question we had. If there's anything else, you know how to get a hold of us. I'll go to the next slide, and I'll turn it over to Scott.
Great, thanks, Matt. That was excellent. Here's some of our contact information here if you want to get in touch with Matt directly, or Onset's information, web address, and you can also contact any of our dealers. So again, we'll be following up with a recording of this in an email. I know the videos were a little sketchy or a little jumpy, so we're gonna clean those up for you before we send that out. And yeah, of course, any other questions, feel free to get in touch with us. And thank you again for joining us. Have a great rest of your day.